is to love what you do. And that's very important. Whatever you are doing, if you start loving it, I tell you, you will find it will be a great source of learning. And I understand this is the last session. So please don't hesitate in asking any question whatsoever you have in your mind, not necessarily related to this session, but if you have any doubt, any question about earlier sessions as well, please throw your query and I will love to answer those questions. But make sure that you are understanding the things. They say suddenly, it's time to start something new and trust the magic of beginnings. And I hope all of you are ready. So we start with it. Thank you. So friends, welcome you again for this session on regression. And let's start our journey. And we move ahead with the quote. It says, what we learn with pleasure, we never forget. So learning with pleasure is always something which we retain with us. And I hope you had learning throughout this workshop with the pleasure, and a lot of things you will be able to retain from this particular workshop. And the best statistical tool for causal research design is regression analysis. Don't think that regression analysis is meant for social scientists. Anywhere where you see some cause and effect relationship, you can make use of regression analysis. We also believe consciously and unconsciously that everything that's happening, it has a reason behind it. It has a cause behind it. So if you are studying some phenomena and you're trying to find out causes those phenomena, I am sure you may be using, or you may use regression analysis, and that will be of great help to all of you. Whenever you have a causal research design, I tell you regression is one of the best tools that you can use. So our agenda for regression is, agenda for this session is regression analysis. And that's defined as you have a dependent variable, which is normally represented by Y, and you have a number of explanatory variables, which are represented by X's. Like you have a dependent variable and a number of variables are causing it. We call them as independent variables. We call them as explanatory variables, and all of them impacting my variable of interest, which is the effect. And this we are saying as cause. And we believe that effect may be product of one cause or maybe a number of causes. And that's the usual simple classical regression model where we have one equation. Alpha is intercept, beta is the slope parameter of the model. Every classical linear regression model is having error term, which is stochastic in nature, probabilistic in nature. And that takes care of what is called other things being constant or ceteris paribus. And we have disturbance term because it helps us in taking care of omission of variables, non-linearities, measurement error, and human indeterminacy. There may be a number of reasons because of which your model will not be a perfect 100% fit model. Some difference is bound to be there, and that difference are called errors. You can call them as misses, shocks, noise. Different terms are being used by different people. And these are the assumptions which we make about a regression model. The mean of the error term is 0. Variance of the error term is constant. Error terms are not correlated with each other. So we have non-autocorrelation assumption. Error term is not correlated with your explanatory variables. Error term is assumed to follow normal distribution, and we are assuming x's are given to us. And you will observe one thing here. Most of the assumptions are about error term. And the reason behind these assumptions is that error term behavior is totally unpredictable. We do not know how the error is going to behave. To discipline error, we have to impose conditions on it, and therefore we find most of the assumptions are related to error terms. Okay, any question about assumptions or definition of the regression? Okay, if you don't have a question, then I have a question. How do you see a difference between correlation and regression? Anyone? Quick. Who is going to give me the differences between correlation studies a relationship? That means correlation talks about relation, association, while regression is based on the phenomena of cause and effect. Correlation is symmetric. You calculate correlation between x and y and x, the result will be the same. But regression is not symmetric. Regression of x with y or y with x will give you two different results. We can determine the impact of each variable on the independent. Ganga, what is this IDV? Independent variable.
Sorry, sir, I wanted to write dependent variable. Sorry.
Okay.
Sorry.
Right. In case of correlation, x and y both are assumed to be random. But in case of regression, y is random because of the error term, but x's are non-stochastic, that's given. So that's how we see the difference between correlation and regression.
Excuse me, sir, could you please explain non-stochastic?
Okay. I think Charu is also having similar question. Stochastic means random, probabilistic. So if you have a process which is moving randomly, then we say it's a stochastic process. It has an associated probability attached with it. And when I say non-stochastic, that means it is not random. It has no probability attached to it. It's deterministic. So that's how we define stochastic and non-stochastic. Stochastic, uncertain, probabilistic, random; non-stochastic, deterministic. Yes, Ritika, correlation describe relationship and regression describe cause and effect relationship. Okay. Pooja, what is your background? Commerce. Okay. What the behavior of share prices? Can you predict what will be the share price of, say, Reliance Industries on coming Monday? Can you predict it? No, we cannot. If you cannot predict something with certainty, that means it's random. It's stochastic. Okay. If I say variable cost per unit is 10 rupees, fixed cost is 10,000 rupees, and production is 1,000 units. Pooja, what will be my total cost? My total cost will be 10 into 1,000 plus 10,000, 20,000. Certain. No uncertainty. No randomness.
Understood, sir. Thank you.
Therefore, it is called non-stochastic, while share prices is stochastic, random. Okay, another question. What tells us cause and effect? Ritika, can you give me the answer? What is that through which we come to know cause and effect? What is that which tells me what is cause, what is effect? Anyone?
Like advertisement on sales.
Okay. Who tells you that? Who tells you that advertisement is having impact on sales?
We are trying to verify. We want to verify whether there is any impact of advertisement on sales.
That you want to verify, Ganga, but how do you know that advertisement has impact on the sales?
Literature review.
Yes.
Yes.
Literature or underlying theory. They say that advertisement has an impact on the sales. But do you get the evidence of this cause and effect relationship in real life or not? For that, you have to use a regression. Regression provides you evidence whether that cause and effect relationship exists or not, but the idea of that cause and effect relationship comes from underlying theory. Yes. So please note that almost all the assumptions are related to the error terms. And biggest challenge is how to get the estimates of alpha and beta. And for that, we have methods of estimating it, the ordinary least square method, OLS, or maximum likelihood method. Both methods gives you the same results in case of simple classical regression model, but we will concentrate on OLS, intuitive, simple to understand. And a very important theorem, Gauss-Markov theorem, that says the estimates which we get from OLS, they are blue estimates. Best because they give you minimum variance, linear functions of variables, unbiased estimates. Linear, unbiased, efficient, consistent, and sufficient. So alpha and beta are to be estimates. And the estimator which we are using is OLS. And this estimator gives me blue estimates. What does it mean? Always use OLS. Because it provides best estimates. But this sentence is subject to a condition. And the condition is your assumptions must be true. As long as your assumptions are true, don't look at anything else. Use OLS. Your results will be always best. And nobody can question your results. Nobody can raise a finger on your results. Issue will come up when somebody points out that this particular assumption is not true. Then how can you say that your results are best results? But if you prove that assumptions are holding in your case and you're using OLS, then your results will be the best results and nobody can question it. And now let's look at the statistical properties of our estimates. They are unbiased estimators, so the expected value of alpha hat is A. Ganga, do you see difference between alpha hat and alpha?
Yes, sir. Yes, sir.
What is that? Whenever you see a hat on some
Predicted. That is
symbol,
predicted.
that means it is your estimate from sample. And this is your population parameter. So this cap, which you see here, that indicates the fact that it is an estimated value. So if I take expected value of the alpha hat, it will give me the population alpha, similarly this, and that the variance of it. And since error term follows normal probability distribution, the distribution of alpha hat and beta hat is also normal distribution. And y is also following normal distribution with mean this and variance, which is equal to the variance of the error term. Mean of the error term is 0, and that's how we get the variance of the error term, and error term follows normal probability distribution. So distribution of alpha hat, beta hat, y, error, all follows normal probability distribution. Should we check normality of X? If you are working with regression, should you check normality of X? That's my question. Anybody? Ganga, you have to report whether all assumptions are holding true or not. Normality is one part of the assumption. So you have to check whether the error term follows normal distribution or not. But that will be only one aspect of the assumption.
No, we need to report normality for Y, predicted Y, and other things. That is what I want.
Only error term.
Okay, sir. Okay, thank you, sir.
Error term is following normal distribution. Everything else will follow automatically normal distribution.
Oh, great, sir. Thank you.
Any question before we go ahead? Now we will estimate, we'll take some examples and estimate our regression equation. So what are the steps which are used in the analysis of regression? Understand your data, summarize through graph and table. That's very, very important. Make a model and get the results of the model, then testing the model and post-estimation analysis, and finally reporting the results. So these are the steps which are involved in any regression analysis. So I'm not going to do this. We are going to make a model, estimate the model, and we don't have the time to go for the testing of the assumptions, but that should also be done. And finally, report your results. Yes, Charu, we have to calculate normal distribution of error term. We are not supposed to calculate. We have to prove or test whether error term follows normal distribution or not. Distributions are not calculated. We have to test whether distribution is normal or not. So let's apply our learning, and I will be using Excel because Excel is very convenient for initial regression models, and every one of you have Excel. So so we have Y and X, and we can make use of the data analysis tool. Data analysis is having data and data analysis. In that, you will see the regression. Which is asking for Y. This is my Y. Asking for X. First row is my labels. Okay. And then I say, okay. Friends, please open up your Excel, go to data and check in that data, do you have the option of data analysis? If you are not able to see it, let me know. because it is an add-in, if you're not able to see it, then you have to add data analysis. It's a very useful utility. Helps you in doing a lot of statistical work, even if you don't have any other package with you. So let me. Pooja, you are not able to say it, data analysis, then you follow my step, go to file. At the bottom of the options of the file, you will see options. Then when you click on the Excel option, the window which you get, in this window, you have an option, add-ins. So click on add-ins. At the bottom of this new pop-up which you get, you have manage Excel add-ins, then you simply say go. And you have a lot of add-ins available. You just tick them and then you say okay. So it will take few seconds and all these add-ins will be added to your data option under the heading of data analysis. I repeat, go to file, options, add-ins. At the bottom of the pop-up window, you'll find Excel add-ins, go, and then you tick. And once you did it, then you get the answer. And you will see in data, the option of data analysis. Okay. First thing is, what is my model? My model is y is equal to alpha plus beta x plus error term. Second, what is my estimated model? My estimated model, you will see here. This is my intercept. And this is my slope. So my estimated model will be y is equal to 39.347 plus 2.827x. That's my estimated model. So this is my alpha. This is my beta. Okay, now let's understand each and every term of the output which we get. Whatever output you are seeing here, almost all this software gives you the same output. Maybe the arrangement is different, but by and large, you will get the same outputs. And if any output you are not able to understand, you let me know. So I start from the top. First, I take multiple R. This is correlation. Between Y and Y hat. So 66.70% is the correlation between the Y and predicted Y or estimated Y. Ganga, why don't we write error? Can you imagine?
So actually, I am not getting. In second case, you have not written errors.
Can you imagine why I'm not writing it?
I didn't get it.
Because our assumption is when we estimate, my error term should be
Ah,
0.
0. Okay, got it, got it, got it. Thank you, sir. Thank you.
That's why we are not writing it.
Thank you. Got it, sir.
So multiple R is a correlation between Y and predicted Y. And if you take a square of it, you get R square. So if I show you, if I take the square of it, you will get R square. Who will give me the interpretation of R square? What is R square? Who will give me idea about R square? Rashika,
Well,
where?
I can try.
Yes, Kavita, try.
So it is the total explained variation divided by the total variation.
Right. So total variation of what?
So it is total explained variation. So explained variation is from the deterministic component, and that divided by the total variation, which is the sum of explained and unexplained variation.
Kavita, if you say deterministic, that means it will not have variation.
Oh, sir, the x's that are there, they are deterministic, right? So it's total explained variation, which is the variation explained by the variation in the
Variation in what?
deterministic component.
Which is the deterministic component?
The x beta is the deterministic component.
Which one?
X beta is the deterministic component.
That explain what?
So the explained variation in that divided by the total variation, which is
कविता total variation किसका? X का, error term का, Y का, किसका?
नहीं सर, डिनोमिनेटर में दोनों का सम है.
किसका सम?
एरर का भी, जो डिनोमिनेटर है वो एरर का वेरिएशन प्लस
X का.
यस यस, एंड
और Y
न्यूमरेटर
का?
में जो है वो
Y का? Y का?
सर y का तो दोनों का सम ही होगा ना. सॉरी, मे बी आई एम मिस्टेकन सर.
It's a total variation of X. Sorry, Y.
Yeah, in the denominator, yes. Yes.
And out of this total variation of Y, how much variation is explained by our model?
Yes, sir. Exactly, sir. This is what I meant. Yes.
By model.
Yes, sir.
So when I say explained variation, this is the explained variation of Y. So how much variation of Y can be explained by my model? And in my model, I have only one independent variable, that is X. So it says 44.44%. That means one single variable X is explaining 44.5% variation in Y, and 55.5% variation is still unexplained by the model. That may be explained by something else, we don't know. That is something which we have to look at. What is adjusted R square? I will discuss it a little later. This is the standard error. This is the, sorry. Standard error is the, also known as standard error of regression. Also, this is equal to standard deviation of error term. Total observations are 24. Okay, so I hope all the items in this part of the table is explained and no questions here, then this is my ANOVA table. This is my total sum of square of y. And out of it, so much is explained by the regression. And residual is your unexplained part. And I show you, you can also get the value of R square from here. This is my explained part. Sorry. This is my explained part. And total is this much. And you will find this is exactly equal to explained variation, R square. Is that clear? And what gives you a feel? I mean, when I say explained variation, what does it mean? I have the total variation 689.26. Out of it, 306 is explained, and that's how we get the value of R square. And if I divide sum of square by their degrees of freedom, I get mean sum of a square. Mean sum of a square is nothing but variance. Now the question is, what is it? What is this number? Anyone? What is this number? 17.3876. What is this number? Sum of square divided by 22. The variance of the error term. And if you take the square root of it, you should get the standard deviation of the error term. So if I take the square root of this number, sorry. And you can see here, this is exactly equal to this number. And F is the ratio of the variance of explained and unexplained, and it is coming to be significant. That means the explanatory power of the model is statistically significant. And then we have the coefficients, alpha, beta. These are their standard errors. And this is the T statistics. Can you imagine what is the null hypothesis for this T statistics? Anyone?
Coefficient is equal to 0.
Yes. Alpha is equal to 0, beta is equal to 0. So you can easily calculate the T statistics, the value of the coefficient, sorry, divided by this. That's how we get the value of the T. Similarly, you can get the value of the T statistics for beta. P values are coming to be less than 5%. That means alpha is significantly different from 0. Beta is significantly different from 0. And these are the interval estimation which we have for the values of alpha and beta. So I hope we have understood each and every item of the model. If anyone have any question, please let me know. Any item which you think you need to understand, you need to talk about. Anybody, any doubt? Make sure that you are understanding each and every part of the output. Nazia, the minimum value of R square is 0 when nothing is explained. And there is no acceptable value for R square. The only thing I can say, higher R square, better is your model. Okay. That's what we did. Data analysis, utility of the Excel. And if you don't have, you can add it.
Good evening, sir. Sir, what all to report the table in thesis?
Madhu, itne saal ho gaye tumhe kaam karte hue.
Sir, it is about reporting T stat P value or to report the standard error. I'm a bit confused.
Okay, don't worry. This is what you want, right? How to report the results.
Yes, sir.
So when you report the results, you should report the following things. Your underlying theory, your testable model, like in my case, the testable model was y is equal to alpha plus beta x plus error. Sample size, your n, estimated equation of the regression, and standard errors of the estimated parameters that we put in parentheses. And you can give a standard error of regression or R square. And all other information we can generate, the readers can generate. So the way we report is, this is my model. I've not written here the sample size, but we have to also tell the sample size. That's your estimated model. This is my sample size. This is the standard errors. This is my R square. And you can put a star if they are significant. If they are not, you leave them as it is. Nadia, just wait. We will talk about adjusted R square. So, Madhu, that's how we report this.
Okay, sir. Thank you.
You can put these stars if they are significant, and normally people use single star, double star, 3 stars. 10% level of significance, 5% level of significance, 1% level of significance. And some softwares put these stars, some do not. But when you report, you have to ensure that you are putting the stars on the significant coefficients. Okay. How do we know whether our regression model is a good fit model or not? Suppose there are 2 models, A and B. How do I know which one is good? What is that we should look at in order to decide which model is a better model?
Sir, we compare the information criteria.
Okay.
KICBF.
Besides that,
R square and adjusted R square.
R square, adjusted R square. We look for F, and we look for individual statistics of each and every parameter. Kavita, since I'm not talking about information criteria, so I'm not put it into my list. Otherwise, information criteria is also one of the important criteria to decide whether model is a good model or not. So you have to look for R-square. Higher it is, better it is. The standard error of the regression, that is the variance of the error term, lower it is, better it is. Significant and significance of the coefficients of the variables. All those things will help you in deciding whether your model is a good model or not a good model. Any question, any doubt, any query if you have? Madhu, if you want to put in the tabular form, okay, so you can write dependent variable, whatever it is, say y, then alpha, beta, R-square, n. You can write here value of the, say, 0.10, put a star, beta 0.005, put a star, and don't forget to write the standard errors below it. And R-square value, n. In a tabular form, you can put it like that. Is that okay, Madhu?
Yes, sir. Thank you.
Okay.
Because I saw some thesis which was reporting T statistics and not the standard error, and therefore I got confused.
But no need if you are saying that it is significant. I can easily calculate T.
Right.
Because
But
T is what? Coefficient value divided by standard error.
by standard error will give me the T statistics.
So I can calculate.
Right. Yes, sir. Thank you.
Okay, just give me a minute. Okay, Charu is asking, what is F? F value is what? F value is a ratio of explained variation divided by unexplained variation. And if it is higher, then it's going to be significant, and that's what we want. We want larger explained part and lower unexplained part. And that's what F represents. Ratio of explained variation divided by unexplained variation. Nadia, we never report standardized betas. We always report unstandardized beta. The standardized beta are reported only when you are comparing the significance of different variables. Otherwise, normal reporting is reporting of unstandardized beta. Okay. Anybody else? Any other question? Okay. Then let's see what next we are going to talk about. Now we take a multiple regression model where we have more than one independent variables. So instead of having one X, I am having number of X's. So we make same assumptions, except that X's are not linear functions of other explanatory variables. So X's should not be linearly correlated. That's our assumption. Otherwise, mean of the error term should be 0, constant variance, no autocorrelation, and no correlation between X's and the error term. Error term follows normal probability distributions. X's are given to us. All assumptions which are same. And again, the method which we use is OLS. So let's take an example and see how do we do it. So this is an example of the salary, average performance rating, experience, and certification. So salary data. So we have the salary data. So I go to data analysis, regression. My Y is salary. And my X's are average performance rating, experience, certifications. That's what we get. So my estimated model is salary is equal to 32.92. I'm just, for simplicity's sake, I'm writing my coefficients in two places of decimals. Plus 1.06 performance plus 0.32 experience plus 1.30 certification. That's my estimated model. So these are my, this is my intercept, beta 1, beta 2, beta 3. And all p-values are coming to be significant. That means significantly different from 0. And therefore, performance is having positive relation with salary. Experience is also having positive relation. Certification is also having positive relation. Okay. Now let's see, how do we interpret this? How will you interpret this number 32.92? If somebody is having performance rating 0, experience 0, certification 0, that person will still get salary, which is 32.92. When all independent variables are 0, what is the value of salary? That is 32.92. Okay. How will you interpret 1.06? What does this mean? Anyone who will give me the interpretation of 1.06?
Keeping everything else constant,
Right.
increase in performance rating by 1 unit.
Salary will increase by
Increase the
1.
salary. Yeah, by 1.06.
The condition is that all other factors should remain constant. No change in experience, no change in certification.
Yeah.
Ganga, if the intercept is coming to be negative, that means what? If the intercept is coming to be negative, that means if everything is 0, still y will take a negative value.
Okay. That doesn't mean the model is wrong, no, sir?
No, nothing.
Okay. Okay. Thank you.
But I think, sir, wouldn't it mean in this particular case that the the estimate is biased because you can't get negative salary? So there must be something must have gone wrong in the modeling that the intercept is coming out to be negative.
For this particular model,
But
it cannot be
we
negative.
normally don't care for intercept because our interest is in the variables. Because
Yeah,
we see variable that causes my salary. So normally we do not give too much weightage to intercept. But you are right, if intercept is coming against your theory argument, then you have to recheck your model. Okay. Similarly, 1.30 means if performance rating is constant, experience is constant, 1 unit increase in certification will lead to increase in salary that's equal to 1.30. And this is my correlation between salary and salary head. That is predicted salary. And this is Rsquare. That means these three variables together explain variation in salary to the tune of 91.35%. And standard error is 1.72. F is coming to be significant. That means my model is having significant explanatory power. And that's how we can understand, our multiple regression model. Let's see what next we are going to talk about. A company wants to see the impact of advertisement on its sales. And sorry. This is the T statistics. Rsquare is coming to be very low. And that's what my scatter plot looks like. Ganga, I need your comment on it. I think you talked about advertisement and sales.
Yes, sir.
Do you think management will be happy with this result?
No, sir, no.
What
No.
should? Don't report to the management or what?
It is not making much impact. Okay.
So what should we do? As a researcher, you should not sit quiet. You should go deeper into it. Find out why this is not happening. Why you are getting this result?
Ineffective advertisement or not reaching the right candidate's target audience.
No, actually, it was found that in the meantime, it has been observed that during the period of advertisement expenditure, prices have increased, resulting into lower sales.
Okay, got it.
अब क्या करोगे? जो
तो
relation था between sales, sorry. The relation which we are seeing between sales and advertisement, इनके relations को disturb कर रहा है क्या?
price.
क्या करें? तो क्या करें इस केस में? क्या करते हैं?
Is as a variable, control variable जैसे भी ले.
Yes, then we should take price as a control variable and run the multiple regression model.
So how to go about it? How to control the price?
By adding it,
Fact.
is one of the variable in your multiple regression, it will take care of it. The challenge is how to control the effect of the prices while determining the relation between sales and advertisement expenditure. So here we have to understand the concept of control variable. And control variable is a variable that is held constant in order to assess or clarify the relation between the other two variables. The basic purpose of the control variable is to filter out the effect and then see the pure relation between advertisement and the prices. I could not get the portal link. Okay. Okay. I think you should understand this. You have a why. So when you control, from y, the effect of the control variable will be filtered out. Then the other variable will explain only this part. And then you introduce your advertisement here. Y is your sales and control is your price. So the purpose of the control variable is to filter out its own effect and then give you a pure relationship between variable of interests. And how it does, I show you. So I take sales and advertisement data. So we have sales and advertisement. So I run a regression. First between sales and advertisement. Sorry. And my X is this. And that's the result which we get. And now you see it's not coming to be significant, but the moment I add the other variable into my model, if I add price into our model, let's see what result we get. And now you can appreciate here, price is having negative impact on the sales. Advertisement is having positive impact and significant impact. So whenever you do any kind of research, you have to ensure that there should not be any variable which is interfering your relationship. If you come across with a variable that interfere your relationship, then you must control for that particular variable. And that variable will be introduced as a control variable. It's like any other independent variable, not different from other variable, but multiple regression process ensure that its impact will be filtered out. So who decides, Madhu, who decides what is the control variable? If I look at price or advertisement, I cannot make out which is a control variable. As a researcher, you have to define what is your control variable and what is variable of your interest, whose relationship you are looking forward.
Yes, sir, the theory.
So control variable should not be confused with control variable, which is an alternative term for independent variable. So that is something which you have to understand. And once we did it, we find the appropriate relation when we control the effect of the price into our model. Okay. So every control variable is introduced as an independent variable, and you have to decide how to interpret and use it. Multiple regression itself doesn't make difference between control and variable of interest. It is you who have to decide what is a control variable, what is not a control variable. I hope discussion is clear to all of you. If you have any question, let me know.
So can't we study R-square after controlling the impact of price?
It will be higher. R-square will definitely be higher.
Can we identify what will be the R-square after controlling the impact of price? Is that possible?
Yes, yes. If you run the 3, this is my R-square, 66.95.
Huh.
And if I don't include my control variable, my R-square is only 4%.
Mm-hmm.
So I can compare.
So that way. Okay.
Because
But
you have
then,
both models before you, na?
yes, no, so I want to ask whether if we are controlling the price factor and then we apply regression, so the R-square has to increase, no? The one
Yes,
which you were
has to
showing green side,
Yes, yes,
green.
it has to increase.
So that increase part.
Otherwise it doesn't make a sense.
Yeah. Mm-hmm. Got it. Okay, sir.
Charu, I don't know. Firm size will be control variable or moderator in relation to book value per share. I don't know. Charu, you have to tell me what is your variable of interest. Only then we will come to know what will be control variables. If firm size is your variable of interest, then it cannot be a control variable. Okay. So learning is that we should not omit variables which are which should be there in our model. If you have omitted variable, then your estimates will suffer from what is called omitted variable bias. So try to include all these significant variables into your model. Otherwise, it might be possible that your model is suffering from omitted variable bias. I think let me give you an example of omitted variable bias. Okay, I have a question. What is the relation between demand of T and anyone? What we expect as a relation between demand for T and price for T. The law of demand says there should be a negative relationship between these two. So we have the data with us, the quantity demanded and the price of the T. Let's run the regression and see what happens. So my Y is quantity of T and my independent variable is price of T. And that's the result which we get. And the result which we get, it shows we have a positive relationship between demand for T and price for T. However, the relationship is not coming to be significant. Sakshi, we were expecting negative relationship, but we are getting non-significant positive relationship. ये क्यों हो रहा है सर? Why this is happening like this?
And sir, R square भी कुछ 6.89 करके है. What does it mean?
बहुत कम है.
Okay, sir.
But why this is happening? Price of coffee omitted variable, right? Because the law of demand says the relationship between demand and supply demand is a function of price, keeping other factors constant. And law of demand says one of the important factor is price of substitutes. And in real life, it's very difficult to keep price of substitute constant. And that's what exactly happening in the coffee case. So actually what happened when the price of tea goes up, can you imagine what will be the impact of the prices of coffee? Prices of coffee will also go up because people will go for substitution and start demanding more coffee. And when price of coffee goes up, it has impact on your tea demand. So I have omitted a variable, and that variable of significance, which is the price of a substitute, and therefore I'm getting results which are biased results. And once you take the price of the coffee into consideration, let's see what we get. So my independent variables are now 2. And now you can see here, price of the coffee having positive impact, tea is having negative impact, and that is significant. So the lesson is we should try to incorporate all possible variables. The moment you ignore variables of importance, then you will start getting biased results. So we have to be careful about this. So let's see what next. Can I increase the value of R square by adding more and more variables into our model to get a better model? So 1x, then I add x1, x2, x1, x2, x3, x1, x2, x3, x4. The moment you are going on increasing your number of independent variable, can you imagine what will happen to the R square? Madhu, what do you mean by not necessary?
Sir, R square may not necessarily increase because increase in variables, we have to look for adjusted R square.
Kavita, what do you say? Pooja, are you trying to say something? R square will always be increasing. Always. Madhu, that's very important thing. The moment you add a variable, R square to badega hi badega, kuch nahi ho sakta.
But we compare adjusted R square. Right?
I'm coming to that.
Yeah.
Coming to that.
Yes.
But what is the problem when you go on adding variables after variables? What is the problem we face? If you add more variables into the model, we lose degrees of freedom. And when you lose degrees of freedom, it impacts quality of your estimates. So now on one end, my explanatory power is increasing. On the other hand, I'm losing my degrees of freedom, and that creates a problem. So what should I do? I'm looking for an R square which has been adjusted for degrees of freedom, and that gives us what is called adjusted R square. R square is not adjusted for degrees of freedom. While adjusted R square is calculated by considering the degrees of freedom. So if you lose a lot of degrees of freedom, adjusted R square penalizes that and reduces its value. So if the gain are less, penalties are more, adjusted R square even may come down, but R square will never go up. So if you want to compare multiple regression model, if we are comparing multiple regression model A, B, C, then we should not compare R square, we should compare adjusted R square. Adjusted R square will give you a proper comparison among different multiple regression models. And how do we calculate it? How do we calculate adjusted R square? It is 1 minus residual sum of square divided by its degrees of freedom, total sum of square divided by its degrees of freedom. And K, the number of parameters which you are going to estimate. Okay. I have a question here. What is the interpretation of R square? What R square represents? अरे बोलो तुम लोग, कभी तो डिस्कशन किया हमने इस पे R square पे. Explained variation. Yes, Charu. So R square represent explained variation. In fact, percent explained variation. But adjusted R square does not give percent explained variation. You know, I've seen many people also interpret adjusted R square in the same way as they're interpreting the R square. No. R square give you percentage variation explained, but adjusted R square does not give you that number. So if R square is 60% and adjusted R square is 55%, then variation explained is 60% and not 55%. So be careful about the interpretation of the, R square and adjusted R square. Adjusted R square is used primarily because of the fact that when you add more variables, you get some benefit in the form of extra explanation, but we lose degrees of freedom. So we are paying a cost for it. To have a balance between the benefit and cost, and to get that idea, we use adjusted R square. Can adjusted R square be negative? The answer is yes. Adjusted R square can be negative. And let me show you an example where you can find adjusted R square negative. So if I take a sales in lakhs, And if you see here, your adjusted R square is coming to be negative. Though I'm calling it an R square, adjusted R square, but still this quantity can be negative. And if this is coming to be negative, that means my model is not right. It's a wrong specification. There is something fundamentally wrong with the model. Any model with negative adjusted R square is not at all acceptable. And therefore, relook your model, relook your selection of variables, relook your data, and then you come out with a model where you don't have negative adjusted R square. Okay, so R square is something which we never like. And if you are getting negative R square, then you have to be careful about it. We never like this, adjusted R square. Okay. Any questions, friends, before we go ahead? Any doubt, any query if you have?
Sir, can you please explain the interpretation of adjusted R square once again, please?
Adjusted R square is used for comparing different multiple regression models. A, B, C, these are three multiple regression models. I want to compare them. For comparison purposes, I will be using adjusted R square. That's the only role of adjusted R square, nothing else. Interpretation of explained variation, that will still come from R square, not from adjusted R square.
Okay, got it. Thank you, sir.
Okay. Anybody else? So
what we will do? What will we do after when we get adjusted R square negative?
you have to check specification of your model, check whether you have taken the right set of variables, check your data, and maybe if there is a need, you can increase your data set. If you do all those things, then you may be able to get the adjusted square non-negative.
Okay, sir. Got it. Okay, sir.
Adjust standard error. Sakshi, standard error of what? Sakshi, standard error of what? Regression model. Okay. Standard error of regression is nothing but the standard deviation of error term. So standard error is nothing but standard error of regression is nothing but the standard deviation of error term. Lower it is, better it is. It should be low as far as possible. Yes. Any other question? So friend, that's all I want to discuss with you in this session. Thank you very much. All the best.
And before, sir, thank you so much, sir. Before we end this session, I take this opportunity to formally thank sir. And so it really matters, and so thankful for like taking out time from a busy schedule and enlightening us with your knowledge and taking all the queries and doubts of each and every participant in so much detail and elaborating such tedious concept in such a simple language which made us learn forever. Thank you so much, sir.
Thank you.
आज तक तो करें।
अंजलि बधाइयाँ।
Thank you so much, sir.
अंजलि बधाई तो ले लो पहले।
Thank
It
you,
is
sir.
still on
Thank
YouTube,
you,
ma'am.
sir. It is
Sir.
sure.
Congratulations, ma'am.
Sir, लाइव को एक मिनट, लाइव को वो कर दो, स्टॉप कर दो।
Ma'am, I can't do. I'm not having the rights right now with me. अब
नहीं,
सीपी सर आप होस्ट बन गए हैं, आप मुझे
ma'am.
राइट से दीजिए।
तो मैं
Ma'am,
क्या
can you hear me? Ma'am,
सीपी सर आप हो सीपी सर मेरे नाम के आगे ना आपको ऑप्शन दिख जाएगा होस्ट बनाने का।
अंशिका के नाम पे आगे।
जी जी। सर जो आपका प्रोफेसर सीपी गुप्ता वाला है ना, उसके पास राइट है उस वाले सिस्टम पे।
अंशिका।
या मेरे नाम के आगे आप जाएंगे ना, वहाँ पे होस्ट बनाने
Make
का
host.
ऑप्शन होगा सर।
excuse me, ma'am.
कर दो।
Thank you, sir. Ma'am, I'm just stopping now. Ma'am, can I stop